Well, hello, my name is Johannes Ulrich, and today I'm going to talk about SQL injection, in particular, how it affects Python. Well, why SQL injection? Isn't it like an old topic? Haven't we talked enough about SQL injection? Turns out the vulnerabilities are sadly still around. So we just had, for example, CISA come out with this advisory. Well, basically telling people focus on SQL injection. It's still a big problem, and they also keep having vulnerabilities, and vulnerabilities not just in sort of WordPress plugins and such. Yes, that of course too, but also like in professional security software even that has SQL injection vulnerabilities, often leading to unauthenticated remote code execution issues. And that's really sort of one of the things with SQL injection. Once you have SQL injection, well, the sky's a bit the limit, or the limit is really sort of the creativity of the attacker, and that's something we should never really underestimate. So let's talk a little bit about what SQL injection is all about, and then later why it specifically affects Python. Now, this is our basic problem. We get SQL injection if we haphazardly mix user data and code. This is actually a bad pattern that you see in many vulnerabilities. So buffer overflow, we're using the same memory for code and data. Even cross-site scripting, you could sort of put a little bit in that category, that you have JavaScript and HTML mixed in with user data. So this is a very common topic. And at first it may not be that obvious. Well, we have these delimiters here, these quotes that delimitate our user data from our code. But turns out that these are not really very strong delimitors. They are actually not even required. And then, of course, by not properly separating this to a database, it's all the same. The user data, the code, it's all the same, and there is no clear distinction here once this string reaches the database. And that, of course, leads into the ability of the attacker to completely rewrite our statements. So in this case, instead of getting the actual price, well, we just get the number 0, I guess. So here we basically just could set the price of the item to 0. There is a solution to this, and that's why I often call this the least necessary vulnerability. And that solution is called prepared statements, sometimes called parameterized queries. Compiled statements, I've seen that said as well, but the way it works is we first send the actual statement to the database, and then we are executing that statement, and when we execute it, that's where we are sending the user data to the database. So we are now properly separating the code, the SQL statement, from the user data. This is not Python, what you're seeing here, and that's where a little bit the problem comes in later, that in Python this looks a little bit different. But I picked this here because this sort of shows really more what's going on, that we first send the statement to the database, the statement will be parsed by the database, and then there will be some memory reserved for user data, but that user data, once we send the database, can no longer modify the actual statement. Now, there are a couple items where prepared statements don't work. For example, if I have variable table names. I ran into this myself on the Internet Storm Center website. We collect log data, and to keep them more manageable, each day I create a new table for the logs that we receive that day. Well, now the table name includes the date. And if I select data for a particular day, well, the table name becomes variable. The way I sort of solved this in my application was similar to what you see here. I have a fixed prefix, and then the variable part is actually just a number. And that, of course, makes input validation very trivial. I just have to check if it's an integer. A more common case where this happens is with these limit clauses. Now, this is always an integer. So again, input validation is not really that challenging here. It's not like, for your standard data that you're sending to the SQL database, things like addresses, names, and such. Where kind of everything goes, blog posts, comments, and for these specific items where you cannot use prepared statements, well, you pretty much just make sure that they're easy to validate. And for the limit, well, they must be an integer. So I cannot use the prepared statement trick here. This doesn't work. I have to fall back to best practice, good input validation before I send the data to the database. Okay, so very briefly here about SQL injection and what it's all about and how to prevent it. So now, how does this apply to Python? In Python, we have a number of different database-specific libraries. That's what we want to focus on here. These are the libraries that allow you to basically send SQL commands to the database. In addition, you also have these object relational mapper libraries or ORM database libraries. I'll talk about them a little bit in the end, but the SQL injection for those libraries is really up to the library to prevent this. As a user, you have less influence over what's happening here. So this is your basic code, what it looks like in Python. We first connect to the database. We send some parameters here, like possibly authentication parameters. Then we create a cursor, and then we execute statements. And of course, that execute part is where it gets interesting from a SQL injection point of view. Now, there are two ways how I've seen this done in Python. Both lead to the same result in the sense that both work, both execute SQL statements, but one of them is safe when it comes to SQL injection, one is not. And I want to give you a second here to look at this so you can see if you notice the difference here. Yep, it's the percent versus the comma. That's our difference here. And that's substantial when it comes to Python. In Python, the percent interpolates strings. There's also format that sort of works a little bit similar, or F strings would be another way sort of how this could happen. But the percent is sort of where I have seen this done wrong most. And what this does is, this parameter, if you want to call it this way, it's not really a parameter, but this data is being inserted into the string before it's being executed. So this is dynamic SQL. And our database receives just a string with no distinction as to what's the data, what's the SQL command. On the other hand, so basically that's what happens here. On the other hand, when we do a comma, well, when we do a comma, then this list here is sent to the database as a set of parameters. And then the database is going to insert it into our placeholders here in the string. So here we leave it up to the database knows this is the SQL statement and this is the parameter. So database first receives the statement, then the parameter, and now we are safe from SQL injection as long as our database libraries do everything correct, but they tend to do it right. There's another syntax that also works. If you prefer named parameters instead of just the %s, you can use this syntax here with parentheses, then the name. And then you can have this little dictionary here with your names and the respective parameters here. So that works too. That's safe as well. What about if there is something that you cannot actually send in as a parameter? So here we have the SKU. We send this in as a parameter. But then we also have a variable table name. Well, that where it gets a little bit tricky. Again, it comes back to input validation, but some database libraries, particularly here the one for Postgres, for example, have little helper functions to help with this. So this SQL.identifier, it makes sure that this is a proper SQL identifier, basically a table name. It also allows a schema name to be part of it. So like schema name dot table name works here as well. And that's sort of one way, how you can deal with the limit, with variable table names and other parts of the SQL statement that you may need to replace that you cannot pass as a parameter. So just a quick summary. Prepared statements is it. That's nothing new, nothing exciting. The tricky part is that it's all too easy in Python to use interpolated strings instead of parameters. So be aware of this. If you must compose a SQL statement, like if you have these variable table names, these limit clauses, then back to input validation. Application design helps here as well to basically make sure that your table names, if you have to pass them, are easy to validate. And then, take advantage of whatever features your SQL libraries offer, like here, SQL identifier for Postgres. I don't think MySQL has something like this for Python, but take a look. And if all fails, there'll always a function to check if you have an integer or such. So that's certainly helpful. Regular expression, if you're really desperate, can of course help in some cases here. What I didn't talk about is capturing errors. That helps, of course, attackers sometimes to exploit SQL injection, and definitely something that you should do properly. You should also watch for these errors. You should monitoring. Python has exceptions to deal with errors, and that, of course, works quite well. What about object relational mapper libraries? I said I'm not really going to cover them much because really it's up to the library here to do the right thing. They often actually don't do prepared statements because they try to be database agnostic, and it can be a little bit difficult to create sort of these libraries in the database agnostic way with prepared statements because different databases tend to be a little bit different in how they deal with that. But then at the very least, they should do some proper input validation, escaping and such. It's up to the library. So pick a library that's well validated, like something like SQL Alchemy or such. Now, what I find sometimes a mistake being done with object relational mapper libraries, these libraries sometimes have the ability to create tables dynamically. So the genius about these libraries is instead of writing a SQL statement where I want to store this item into the database, I just pass an object to it and say, hey, store this object in the database. And then SQL Alchemy, for example, can create the tables on the fly. If you all of a sudden you're sending your object, it doesn't have a table for yet. The problem is that now your code needs the ability to create tables. So if you're taking advantage of these features, you often end up with users being used to connect back to the database that have these overly permissive permissions, and that's something you have to be careful with. Input validation, never wrong to make sure that you're not sending garbage into the database, so definitely do that. Well, that's it here for today. Just want to point out, one reason we created some of these videos. Jason is also going to create some. Is we have Sans Fire coming up in July. So take a look and hope to see some of you there. In particular, we do offer our web application security class live at Sans Fire. Over the last couple of years, of course, we did a lot of live online, and we still offer every class pretty much that we have live in the classroom, also in an online version. But I always tell people, I don't see your frustrated faces. There's so much more that we can offer in the in-person format. So hope to see some of you then in class at Sans Fire in Washington, D.C. Mid-July. Thanks. And if you have any questions, you see my email address here. The URL jbu.me links to various social media profiles that I maintain, and the QR code allows you to directly register then for the class. Thank you.